We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India.
What do you say about analog to digital conversion? There are different terminology are available to we can easily demonstrate what is analog, what is digital. First is analog. Analog, it means the continuously valued signal such as temperature or speed with infinite possible value in the between. What is digital? Digital, it means a discretely value signal such as integral encoded binary. Analog to digital converter is just like as ADC, analog to digital converter, AD, A to D, converted an analog signal to the digital signal. What is analog signal? Analog signal it is which is directly measurable and quantity in terms of the some other quantity. For example, for the analog signal is that the thermometer and car speedometer. Thermometer generally it is used for the mercury height rise, in which we can easily measure the mercury power, and the car speedometer we can easily measure the needle move further right as when we accelerate. Digital signals. Digital signals have only 2 states. Digital computer, we refer to the binary state 0 and 1. 1 can be on and 0 can be off. Example for the digital signal is that light switch can be either on or off. Door to room either open or close. Analog to digital converter, it is a basic principle. The basic principle for the operation to the analog to digital converter is the use of the comparator principle to determine the whether on or off to turn for particular system on the particular bit of the binary number output. It is a typical for the analog to digital converter to use the digital to analog converter ADC to DAC to determine one of the input to the comparators. This is a quantization. In this quantization, before explaining this quantization, first we have to concept about what is quantization. Quantization is the process of converting the sample continuous value signal into discrete value of the data. It means आपके पास जो भी कोई सिग्नल है इस सिग्नल को हम लोग डिस्क्रिटाइज करते हैं, स्मॉल छोटे छोटे पार्ट्स में हम लोग डिवाइड करते हैं. Here one graph is available. In this graph we have to find out the velocity maximum in the discretization parts 001, 010, 011, 100, 101, 1110, 1111, so on. Quantizing. Quantizing, it means the number of the possible status that converter and the can output is. It means the quantization which can be find out by the some equation. Capital N is equal to 2 raised to n, where small n is equal to number of bits in the analog to digital converter. For example, 3-bit analog digital converter, it means capital N is equal to 2 raised to cube, it means 8. For example, analog to digital quantization size, we have to find out that Q is equal to V maximum minus V minimum upon N. If we have to put an example that if V maximum is equal to 10 watt and V minimum is equal to 0 watt and N number of bit for the analog to digital converter is 8, then we can find out the analog to quantization side is 1.25 watt. Analog to digital conversion step process. Quantizing, it means breaking down the analog value is set to the final status or finite states, including assigning the digital words or number to each state and matching to its input signals. For example, we have to consider some explain the quantization example. Example here is that you have the 0 to 10 volt signal, separate them into the set of the discrete states with 1.25 increments. How do we get the 1.25 watts? Discussed in the previous session. Here is the output state 0, 1, 2, 3, 4, 5, 7, and discrete is the range from 0, 0 to 0.125, 1.25 to 2.25, 2.50, 3.75, 3.75 to 5, 5 to 6.25, 6.25, 7.50 up to 10. Step 2, encoding. In this encoding, we have to assign the digital value. It means binary number to each state to computer read. output status 0 to 7 and output binary equal is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. It is denoted as on for a open or closed system. Sampling. What is the sampling? Sampling, it is the process of taking a sufficient number of the discrete value at a point on the waveform side that will define the shape for the waveform. The more sample you can take, the more accurate define the waveform. It converts analog signal to the series of the impulse and each represented the amplitude of the signals at given point. This sampling can be result to give up the signals at given points. This is sampling waveforms. Collect sufficient data for the correct representation. The continuous time signal. First and second and third. This is the sampling graphs. Basic types. EDC converted basic types. Flash EDC. Second is the digital ramp or dual slope or counter slope EDC. And third is the successive approximation EDC. Flash EDC. Flash EDC in this it consists of the series of the comparators in which one comparing the input signal to the unique reference voltage. And another thing is that in the flash ADC, the comparator output connect to the input primary encoder units and which produce the binary output 0, 1 or 1, 0. This is the flash ADC output. This is the NOT gate can be used for this comparator. In this the circuit priority encoder 0 to 7. This is the primary binary output D0, D1, D2. How the flash work? As the analog input voltage exceeds the reference voltage at each comparator, the comparator output will sequentially high rate. The priority encoder generated a binary number based on the highest order active, ignoring all the active inputs. This is the ADC output, analog input and digital output. This is flash. What is the advantage for the flash ADC? Main advantage is simple in terms of the operation theory, the most efficient in terms of the speeds, very fast, limiting only in terms of the comparator as well as gate propagation delay. While there is some disadvantage drawbacks for the flash is that like lower resolution, expensive for each additional output bit. The number of the comparator double for 8 bit 2 raised to n, it means 2 raised to 8, 256 comparator needed. Dual soft, also known as counter ramp on the digital ADC. Dual slope ADC commonly used in measurement instruments. This is dual slope ADC circuit. Dual slope functions. The dual slope ADC functions in this manner. When any analog value is applied to the comparator, begin to charge in the linear manner and oscillate the pass to the counter. The counter continues to the count until it reach predefined value. Once this value can reach the counter stop and this counter is the reset. The control logic switch in this output to the input to the first comparator to the reference voltage and providing the discharge path for the capacitor. As the capacitor discharges a counter out count, and when the capacitor voltage reaches to reference voltage, then the voltage slope the value can be stored in the register. This is successive approach ADC. In this ADC, much faster than it is digital ramp ADC because it uses the digital logic system, and digital logic system convert on the value to the input voltage. And comparator and DC are usually the process in which first start clear all the bits, clear MSB, clear set 1. If DAC output, what is DAC output? Condition that here all the bits can be check or not. If check yes, the conversion finish and number register, otherwise no, the clear bit to set to check. Successive approximation ADC. So successive approximation ADC, it is approximation register to add to circuit. Instead of counting up to binary sequence, this register count by trying all the value bits starting with MSB and finish with the LSB. The register monitors the comparator's output to see if the binary count is greater than or less than analog signal input and adjust the bits accordingly. This is successive approximation ADC circuit. This is output of analog to digital. This is AD tape comparison. This is ADC resolution comparison. 3 types of ADC: dual stop, flash, or successive approximation. Here is a comparison for the speed and control cost for the three types of EDC. Duals of have a speed relative, cost relative. Flash have a slow speed and medium cost. And success have a very fast speed and a very high low cost. Example of the ED converter. This is the microphones, strain gauge, thermocouple, voltmeter and digital multimeter. Thank you.